Hey folks, it's Matt. Recently I had the opportunity to spend some time studying Azure Synapse Analytics, and I wanted to share a high-level summary of what I learned so that you can determine if Synapse is a good match for your data engineering needs. In 2019, Microsoft rebranded their existing Azure SQL Data Warehouses product to Azure Synapse Analytics and began overhauling and expanding its feature set and continues to improve them year after year. At its core, Synapse Analytics takes a number of existing parts of Azure and wraps them all together under a single unified banner and backs it with a powerful and scalable data processing engine. Now, Synapse Analytics can repeatedly ingest data from a variety of sources and providers and then transform and store that data using the same core pipeline features and code present in Azure Data Factory. But it does it with enterprise-level scalability, monitoring, and management capabilities. Now, all of this lets Azure Synapse Analytics become an augmented data warehouse that lets us consume its data by providing integrations with Power BI, Azure Machine Learning, and Azure Data Explorer, to name a few. This allows Synapse Analytics to serve as an extract, load transform, and batch processing pipeline for large-scale data sources and support real-time analytics needs. Let's look into each one of these areas in a little bit more detail. In Synapse Analytics, you can define any number of data sources to feed into your Synapse workspace. These sources could be SQL databases like Azure SQL or Postgres, or they could be NoSQL databases such as Cosmos DB. Synapse Analytics also supports blob, file, and table storage, as well as data lakes and Spark-based data systems. Now, one thing to highlight here is that data can also be ingested from outside of Azure via connectors to other cloud providers or even by installing an integration runtime on premises in order to provide self-hosted data to Synapse Analytics for a hybrid cloud scenario. Microsoft gives us a very robust copy data tool that allows you to copy data from your data sources into your data lake. This copy operation can be run manually, can be given a loose schedule, or can be run on a tumbling window for recurring intervals like weekly tasks. Synapse also lets you define something called a mapping data flow that allows you to aggregate, filter, sort, and otherwise transform the data that you're loading. You can even merge together multiple data sources via a join operation. If you've encountered mapping data flows before in Azure Data Factory, Synapse Analytics actually shares a lot of the same underlying code, so you should be familiar with many of these features. Let's talk a little bit about transforming our data. Now, Synapse allows you to define pipelines that can trigger tasks like mapping data flows and data copy tasks. Pipelines has actually over 90 different activities for data processing and transformation, including the ability to run custom code in a Spark or a Databricks notebook. One of the reasons that Synapse is so scalable is because it relies on two separate but related pools, a SQL pool for querying and a Spark pool for data processing. In a SQL pool, there's a single control node which receives and distributes queries to its individual compute nodes. Now these compute nodes, they're responsible for executing queries against the data that they store and then returning the results of those queries back to the control node. But it gets complicated because there's actually two different SQL pool models available. There's the dedicated SQL pool model, and then there's the newer serverless SQL pool model. The dedicated SQL pools are closer to a traditional database model where you're paying for dedicated resources based on how many compute nodes you think you need. When a query comes in, the control node figures out which compute nodes are going to have the relevant data, and it asks them to run specific queries against the data that they're storing. Now, compute nodes can be run in round-robin mode, where the data is distributed evenly between all of the compute nodes, in hashed mode, where data goes to different compute nodes based on the type of data or the values of the data, or they can be run in replicated mode, where the same data is stored on every compute node. Now, round-robin is the default and has an average overall performance, but hashed mode performs very well for larger data stores, but it can be a little bit imbalanced as to which nodes have which data. Finally, replicated is best for small data stores that have a very high performance need. So overall, dedicated SQL pools are great for high performance and high volume data processing, but they can be a bit too expensive for smaller workflows. Server SQL pools address this by operating under a different model. Instead of declaring the number of compute nodes you want up front, Azure stores your data outside of its compute nodes. When you need to run a query against them, The control node analyzes that complexity of the query and it sends it to an appropriate number of compute nodes from Azure's overall compute node pool for the entire region serving all of its customers. These compute nodes that you're effectively renting then access your stored data and return the results. Now, this isn't as fast as a dedicated pool, but it is usually cheaper for scenarios where you are infrequently querying your data store. If SQL pools are what we use to query our data, then Spark pools are what we use to work with the results. Synapse Spark is Microsoft's variant on Apache Spark, and that's purpose-built for Synapse Analytics and can run dedicated notebooks to run custom code against data in our data lake. Now, like SQL pools, Spark pools follow a distributed model where a single driver node hands off tasks to executors. Those executors then run those tasks on slots in various cores that they have available. This allows Spark pools to dynamically scale up and down to meet your analytical needs, or even shut down entirely when they're not being used. Spark notebooks can run code in Spark SQL, Python, C#, and Scala. Notably, they cannot run any R code as of this moment. Once data is loaded, it can be sent to a number of services outside of Synapse Analytics. Most interestingly to me, you can use Synapse to trigger an Azure Machine Learning pipeline and even generate Azure automated ML code in notebooks from data in your data lake. On the data analysis side of things, Power BI can be linked to Synapse Analytics to provide a dedicated visualization tool, allowing users to report on data in their data lake or create dashboards for key stakeholders. Azure Data Explorer is an interesting data exploration and visualization service that seems to be rapidly growing at the moment, and there are early signs of some promising integrations between the two services as well. Clearly we can do a lot with Synapse Analytics, but it has some solid enterprise capabilities to talk about as well. So Synapse Analytics gives us a dedicated central pane to monitor and manage all aspects of the data warehouse and our processing pipeline, including both SQL pools and our Spark pools as well. Additionally, Azure's standard identity management capabilities can be fully applied here, including managed identities, service principals, private endpoints, and firewall rules. Finally, data security is alive and well here, with Azure giving us encryption at rest via transparent data encryption, column and row security to restrict who can see what data, and data masking to protect sensitive data. Azure Synapse Analytics wants to be the cloud-based backbone for your entire data infrastructure. It offers scalability and management features needed to meet the needs of the enterprise, and it has a usage-based pricing model and serverless options to make Synapse Analytics viable for individuals like me and small businesses as well. Overall, Synapse Analytics is a very powerful and capable service for your data processing needs and integrates well into other offerings, including Azure Machine Learning. Thank you for watching, and I hope you found this talk informative. Please feel free to leave a comment letting me know what aspects of Synapse Analytics interest you the most, or the types of tasks that you want to perform with it.